This is our Video-2 in drone LiDAR training series. If you haven't watched Video-1 yet, please go and check it out. The link is in the description. In this video, we will learn where drone LiDAR is commonly used. This is an important question. If you know this, it will allow you to provide the best possible solution to your clients. The biggest advantage of LiDAR is its ability to penetrate dense forest, which is not possible with photogrammetry. Another significant advantage is LiDAR capability to identify small objects like power lines. A third advantage is that LiDAR can operate both during day and night without requiring sunlight. Fourthly, data acquired through LiDAR is more accurate for constructing 3D models, especially in scenarios where photogrammetry may struggle, such as areas surrounded by trees or buildings. High data density is another advantage. LiDAR data is dense, aiding in the creation of detailed 3D models. Furthermore, LiDAR generate data can easily overlay with other dataset, a topic we will cover in detail in our data processing training series. However, there are some disadvantages of using LiDAR. The first is that LiDAR has a limited range and the drone must operate within this range. Since LiDAR can identify small objects, adverse weather conditions with water particle in the atmosphere can affect data quality, making it unsuitable for use in poor weather. LiDAR data is not colorized like orthomosaic maps. Objects are identified based on the shape of the point cloud. Now, let's discuss the difference between LiDAR and photogrammetry. We will also explore some examples to understand when to use LiDAR or photogrammetry. Let's consider scenario 1. A project site survey for a solar power plant installation requiring contour map with 2-meter intervals, digital terrain model, digital surface model, and a classified point cloud. LiDAR is preferable in forested area due to its ability to penetrate dense vegetation and provide accurate result. Scenario 2. A survey on flat land for a solar power plant installation needing contour maps with 2-meter interval, DTM, DSM, and orthomosaic. In this case, where orthomosaic is required, photogrammetry is more feasible and results are accurate. Now, let's discuss a case where both LiDAR and photogrammetry are needed. In scenario 1, if orthomosaic is also required, a combination of LiDAR and photogrammetry is used to overcome the individual disadvantage of each method. For example, the DJI L1 sensor integrates LiDAR with photogrammetry, featuring both LiDAR and RGB camera capabilities for data acquisition. This approach is particularly useful to overcome the limitations of either method. That's it for today. Meet us in LiDAR training series video 3. If you found this video informative, please like, subscribe to our channel and visit our website droneschools.in. Thanks for watching.